Hello everyone, this is A.THASNI from Department of Computer Science and Design. So today we are going to see about fundamentals of computer networks. In that we are going to see about the transport layer. So in that we are going to see about the introduction of transport layer and its protocols. So now we are going to explore in the DT concept, like how exploring how modern communication protocol adapt to meet evolving the application needs through systematic innovation. In that we need to understand, empathize the problems, like the applications need for the communication through transport layer. So the application across the internet need to send and receive data reliably and efficiently, regardless of the underlying physical infrastructure. Example like logical communication, like provides seamless communication between application process, abstracting away complex physical network details, and its user experiences creates the illusion of a direct, reliable connection from the user's perspective. The core problem we need to define here is mismatch in services, like the challenge that we face, like in early transport protocols like TCP 1981 and UDP 1980 were foundational but don't fully meet today's diverse application demands. So the one size fits all approach is a basic TCP UDP leads to limitations for modern specialized application with unique requirements. So here the confusion is like RFC 9621 highlights the inconsistent naming and its functionality across different transport APIs and it causes confusion for developers. So the application where we created a struggle to access the specific transport features they need for optimal performance. So here, the prototype that we are going to main action for just the key transport protocol is action is TCP, which is a transmission control protocol, and UDP, which is called as a user datagram protocol, and TLS and DTLS, like which are the security purpose. Here, TCP is nothing but which is a workhorse kind of thing for a reliable and ordered data delivery, which ensures the package arrives correctly and in sequence through acknowledgement mechanism and transmission. Whereas UDP is a lightweight option, like prioritizing the speed over reliability, like ideal, which is ideal for streaming and gaming, where occasional packet loss is acceptable, but the latency is low and which is critical now. For example, like during the gaming or through any stream live is happening, means we are using this UDP protocol. So TLS and DTLS is a transport layer security, which adds security guarantees, privacy, integrity, and identity authentication, which is all in the security level, on which top of TCP and UDP for secure communication. So the foundation, if we are seeing like TCP and UDP, which enhanced by the security means in applications where user programs requesting for data transfer, and then TLS and DTLS, which is a security layer providing encryption, and TCP and UDP, which is a transport protocol with the different guarantees, and network layer, which is a packet routing and addressing. So here, how we are going to test? What is the need for the specialized service, which is under the reliability, security, and low latency multipath support. So reliability, which ensures the data arrives without any loss of corruption through acknowledgement, retransmission, or error detection mechanism. For example, during the file transfer or emails and database transaction. And whereas security, which is protecting data from eavesdropping, tampering, and ensuring the sender's in identity through the encryption and authentication. For example, secure messages or a HTTPS link or a financial transaction, etc. And low latency, which is minimizing the delay for time sensitive application where real-time interaction is critical for the user experience. For example, like during your video conferencing or online gaming or live streaming, etc. and which support the multi-path support, which enhance the resilience by dynamically using multiple network paths or interface for improved reliability and performance, like as I explored in RFC 9621 and SCT. So the future, the upcoming, how it will be like a flexible transport service AC API and TS API, which is an event-driven architecture, dynamic protocol selection, and unified access. Which is the event-driven architecture is RFC 9621, which proposes an event-driven API that allows application to leverage diverse transport capabilities through asynchronous notification. Whereas dynamic protocol selection, which is architecture which enables implementation to multiple protocol like IP address and path dynamically based on network condition. Unified access is nothing but which provides the API for common features which allowing access for the advanced use cases. Here, we are going to see about the dynamic transport, which adapt to the multiple application needs. For example, like a multiple path and or selecting the any protocol or in relevant to configuration and application goals and runtime adaptation. So the conclusion here is how it evolved for tomorrow's internet. Like transport layers, which is not static, it is a dynamic space evolving to meet ever increasing demands of application, like continuous innovation, robust service, or flexible architecture. So these are all the things which is going to be the upcoming through the transport layer. So here is the mind map of how it works. All we seen in this. So this is the mind map of the transport layer.